So I wanted to review some of these 12 leads and lead twos that we posted last week in the lab section. I know that's one of the things that I said we needed to work on, so we're going to take some time to work on it. I'll move through this with you, so I'm going to go through it just like I would on the road. So I can tell you if I look at a rhythm and I don't know what it is immediately after looking at it. So if I look at lead two here and I don't know immediately what I'm looking at, then I'll go straight to the 5 steps. I'm not going to mess around staring at it for a long time. The 5 steps are going to help me tell exactly what it is. So in terms of rate, again, we'll zoom on lead two here. The easiest thing I find, and I'll use one that's not necessarily as regular here, is I'm going to count the small boxes and divide by 1500. So we know for every big box, so for every big box, we have 5 small boxes. So we've got 1, 2, 3 big boxes. And then I have 1, 2, 3, 4, 5, 6 small boxes. So 15 plus 6 is 21. So overall, I've got 21 small boxes. So if you're not using the monitor to determine your rate, I'll divide 1500 by 21, and I'm not doing that in my head, I'm doing it on a calculator right now. So 1500 divided 21 is 71. So that tells me that the rate of this is 71. It's one of the most accurate ways that you'll determine rate. That's how the cardiac monitor determines rate. So the rate is 71 beats per minute. Next thing I'm going to do is determine the rhythm, the regularity. Again, this one is pretty dead even, so it's easy to look at this, and again, easy to just look at it and see that it's regular. If you're super uncertain about the regularity of the rhythm, get a piece of paper, put it over top of the rhythm, draw lines where the QRS complexes are, and then slide that paper down the rhythm, and you should be able to see if the QRS complexes line up. So we know we have a regular rhythm here. And again, just by looking at this one, it's easy to tell that it's regular. Next thing we're looking at is, are there P waves present? So I'm going to, again, zoom in here and give you a little bit of a closer look. So I'm looking at lead two and I don't see any P waves. So if I'm looking in this area here, I don't see any P waves present. And I'm not, again, it's not one of the things where you're searching and looking really closely. Again, as I look at this, I don't see P waves and I take that for what it is. So I don't see anything that would resemble a P wave. There's definitely no consistent positive deflection, so we have no P waves. Makes it easy because if I have no P waves, then I've got no PR interval. Last thing I'm looking at, and remember, this is usually before we've printed our 12 lead, I'm looking at lead 2 for my QRS complex. Is it narrow or wide? Here I've got 1, 2, just on the cusp of 3 boxes. So if I had to guess, and again, you need the 12 lead to confirm in some of that software to really confirm, I think we're just at 120 milliseconds, so we're just below. So it's borderline wide, but from my first kind of glimpse here is I don't think that it is wide. And we'll talk about what that means for us in a second. So it's less than 120 milliseconds. It may be 119, but I think that it's right on the cusp there. So I've got a rhythm that's at 71 beats per minute. It's regular. And I have no P waves. And this tells me a lot. And the regularity is the first piece of it. So the regularity tells me that the rhythm is coming from the same place every time. So whoever's creating this impulse or whoever's generating the impulse, it's happening at the same place every time. Narrow QRS complex tells me that it's traveling down the bundle branches at roughly the same time, and it's not being generated from the ventricles. So I've got a narrow rhythm, which I think is being generated from above the ventricles. It's not being generated from the SA node or the atria because I have no P waves, so that means it has to be a junctional rhythm. So no P waves, narrow QRS, regular rhythm. What's happening is there's someone in here in the junction saying I am going to be the pacemaker and sending that impulse down the bundle branches. So what we have is a junctional rhythm. What you usually have to determine is it a junctional bradycardia, is it a junctional escape rhythm, or is it a junctional tachycardia? Is an accelerated junctional rhythm, so there's lots of different things that we can look at. The big difference is the speed of it. We know that the junction typically fires between 60 and 80 beats per minute. So because this is at the junction's normal rate, this would be a junctional rhythm or a junctional escape rhythm. It means that the rhythm is occurring at the junctional rate. If this was between 80 and 100, it'd be a junctional tachycardia or accelerated junctional rhythm, and if it's above 100, it's a junctional tachycardia. So this is a junctional escape rhythm. and we know it's at 71 beats per minute. And the labeling is important. So you should be putting what we're looking at, or you should be putting the rate of the rhythm there to name it properly. If we take a look at the 12 lead, so we've named our lead 2, it's a junctional escape rhythm at 71 beats per minute. If we take a look at the 12 lead, we're going to do a quick scan for any elevation. So first thing I'm going to do is look at V1, 2, 3, and go right down the list. Do I see any elevation? The way that I'm typically doing this is if I have a piece of paper, if this is a printout, you're always comparing your ST segment to the PR interval of the next or the subsequent complex. So I'm basically going to draw a line like this. I'm going to line it up with my PR interval, and I'm just taking a quick look here to see, do I have any ST elevation? So maybe a little bit here, maybe 0.5 millimeter there, nothing here. I get a flipped T wave here, and maybe a little bit of depression, if you look there, but no elevation. Same thing here. So I go to AVF, no elevation. Flip T wave again in V1, and we'll talk about in a second why we expect that. V2 we have some, we have no elevation here. And we'll go through. So again, this one's pretty easy for me. This is the only one that I might have to take a second look at. The complexes are a little, the baseline's a little off here, but even here, if anything, I've got maybe 0.5 millimeter of elevation or less. So no substantial elevation here when we're looking at the ST segment. If you're having a hard time finding the ST segment, we've got our Q complex here, which is pointing down. Our R is coming up, and our S is this deep dive here. So the ST is coming up as the S turns to the T. And what you can see is, so this is our S coming up here, and see how it changes deflection? That is the ST segment, or the J point, that's that turn in deflection from the S wave to the T wave. So I'm looking right here. So again, if I draw that line from across from my other PR interval, I'm not looking at any ST elevation there. So I don't see any ST elevation. I can tell you there is something else going on. So the next place I'm going to go is to V1 and V2 and take a look at what the QRS complexes look like. V2 has this very prominent kind of bunny ear appearance, but even in V1 we can see up, down, and this big up. This is what you would call an RSR prime, meaning the second one is bigger or it's larger. Regardless, we know that when we have that upward deflection or an RSR prime, it's most typically a right bundle branch block. So what's interesting about this one is our QRS is less than 120 milliseconds. So this is probably what we would call a borderline right bundle branch block. So the patient isn't fully blocked yet. We're just on the cusp of it. So in the 12 lead, what I'm recognizing here is what we would call a borderline right bundle branch block. So no ST elevation, normal in terms of any blockage or anything like that, but we potentially have a right bundle branch block. What's interesting about the right bundle branch block is because we have this big upward deflection, you expect some reciprocal depression. So again, we have this upward deflection, so you expect some reciprocal depression. So understanding that this is a borderline right bundle branch block can be important because it tells me that this depression I'm seeing, or this potential depression I'm seeing, is more related to the bundle branch block than it is to a potential blockage. So it just decreases my concern for seeing that. So that's what we're looking at in this rhythm. Hopefully that was helpful. We're going to move a little bit more quickly through the other ones as we kind of go through it now. So let's get back over. So next rhythm, we're going to do the exact same thing. I don't know why they've labeled these with U's, but really we're talking about the same thing here. So we're going to look at lead 2 first. So I look at my rate. What's interesting on this one is I don't have a set rate because I'm seeing some beats, or I'm immediately recognizing there's drop beats here. So I'd have to use my monitor. Again, if I'm looking at the rate without the dropped beats, you can count in between the QRS complexes, but that's harder on this one because the rhythm is irregular. So the way we would calculate rate in this instance is we would take a strip of 6 seconds or 30 big boxes. So we can count them out here. So we'll zoom in on our lead 2 again. We'll just start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 24, 25, 26, 27, 28, 29, 30. And what you're going to do is you're going to look at the number of QRS complexes in that 6-second strip. So we've got 6. So easily, because this is irregular rhythm, we use this method, and we know that we're looking at 60 beats per minute. So again, this method is much more, it's easier, better for when we're looking at irregular heart rhythm. So we've got an irregular heart rhythm. So we know that our rate is 60 beats per minute. Zoom back in here. So we've got a rate of 60 beats per minute. When I look at the rhythm, what's interesting about it is I see a fairly regular pattern here. I've got 1, 2, 3 impulses. 1, 2, 3, drop beat. 1, 2, 3, drop beat. What is interesting about it here is I've got 1, 2, 3, 4, which is a little different. So what we'd see here is it's irregularly irregular. So again, if I was looking at just this piece here, this would be regularly irregular. If I'm looking at all of it, I see, well, this doesn't match the irregularity that I see here. So this one is actually irregularly irregular. And I can tell by looking at this already, there's a couple of things going on here. So I'm now going to look for my P waves. So I take a look, and again, we can zoom in our lead 2 here. So if I see P waves, so I see a P wave here. So this is a P wave. Circle them in green here. So I got a P wave here. I see something going on here, which I think is a P wave. And when I look at as I get to the next T wave, I'm wondering, well, is the P wave in here somewhere? Because I don't see it. And then I get this drop beat. There's no QRS complex that follows this P wave. So I'm noting two things here. I'm noting where the P waves are, and well, do I have a QRS complex after everyone? No, I don't. I'm missing a QRS complex right here. So go to the next one, P wave. Okay, P wave getting a little further away here. And again, look at this little notch. We don't see this every time. So that's got to be the P wave. It's hiding in that T wave. And then, okay, I see another one, but I'm missing the QRS complex here. I've dropped a beat again. Okay, let's keep going on. Okay, I've got a P wave here, P wave here. Same thing, I got this weird little notch in my ST segment. I've got a P wave here, and then I've got another QRS complex. So here I'm not seeing any loss of QRS complex. So we'll keep that in mind, and we'll go on to the next one. So the next piece that we're going to look at is our PR interval. So we know that P waves, yes, they're present. So we've got P waves, they're present and upright. They're upright. Not all of them have a QRS. So some don't have QRS, which is concerning. So PR interval, again, if I zoom back in here and I start looking at this PR interval, okay, it's a little long here. If I'm looking at the boxes, 1, 2, 3, 4, 5, 6, 7, 8. So I mean, long PR. So we know, okay, is it a first degree block? Well, let's take a look at this one. Well, that's longer. And if the other one's hiding in here, well, that's even longer. Okay. And then, oh, I've got no QRS following here. So automatically, you pretty much know what this is. I've got a lengthening PR interval. So short, okay, longer here, then I miss no QRS. So, okay, I'm just kind of seeing a trend with this. Same thing. Okay, longer yet. Again, you'd have to count this one. Maybe this one's even longer than what we're seeing before. So I'm seeing this progressive lengthening. So that's typically what I would just note is instead of saying what the length of each one is in this case, I would just say we have lengthening, and then drop. QRS complexes are narrow in this case. You don't really have to track them to know that they're narrow, so we can just see that they're narrow. So now I've got a good idea what's going on here. I've got narrow QRS complexes. I've got P waves present, but the PR interval lengthens before every QRS complex. One thing that's interesting is you can look at is the P waves look the same every time. So if you look at these P waves, it's not like they're changing the way they look. They might be hidden in these T waves, but every time I see a P wave, it looks the same. So what that typically tells you, if your P waves look the same, is that your impulse is being generated from your SA node. So I see a P wave and a PR interval, so I know the impulse is coming from my SA node. It's traveling down, and likely what's happening here, and we know when we have a lengthening PR interval, is that we have some sort of block. So we likely have an AV block here. So as it travels to the AV node, it's becoming blocked, or it's getting blocked as it hits that AV node, and that's why we get that lengthening QRS complex. So this would be a second degree block. So if we're naming this properly, we'd call it a sinus rhythm. Because we know it's coming from the SA node, so it's a sinus rhythm with a second degree block, type 1, at 60 beats per minute. So that's how you would be naming this type of rhythm. So if we look at the 12 lead, again, we can take a quick look at our 12 lead here. And I look to my ST segments. I'm going to do the same thing before, and I'll go through this one more quickly. I'm not seeing any ST elevation. So when I look at basically these, I'll show you the same kind of method here. When I'm comparing them, again, that looks okay. This looks okay. If you're having a hard time with the ST segment on this one, again, I don't have a real defined S wave, but we've got our QRS complex. And this is the point where we're seeing that transition to the T wave, or this is where we're getting that transition. Again, we see that change in the concavity of the rhythm or the interval. That's your J point. So it's quite low in this one. So again, we can tell that there's not really any elevation going on here. And I can just go through that. Here, maybe a little bit. Maybe we've got small enough, but again, nothing major. And we go through all of these, I'm really not seeing any ST elevation. I do see some peaking of the T waves in before here. So the T waves are a little bit larger than normal, but I'm not seeing any ST elevation. So I would call this 12 lead normal. I'm not seeing anything that's jumping out to me on this 12 lead. So if we continue on to our next one, we're going to do the exact same thing. So I'm going to take a look at the rate and rhythm. What's interesting about this one is on first glance it looks regular, but as I take a closer look, I'm saying, well, that is a long gap there, and this is a long gap, this is a long gap. These don't look the same. So I'm seeing some irregularity. So I'm just gonna, again, I'll count my 30 boxes out and I'll get my rate that way. So 8, 29, 30. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 130 beats per minute is what we're looking at. So my rate is 130 beats per minute. I look at the rhythm and it looks irregularly irregular to me. So again, when you see just these varying, like this is all over the place in terms of distance. When I draw it in here, you can really see the difference between them. There's no rhyme or reason to what the sizes are here. So we're looking at an irregularly irregular rhythm. Now, again, we're going to look at our P waves. As I mentioned before, or maybe I didn't. We're looking at P waves. V1 or lead 2 are the best. So I'll move up to lead 2 here first because that's where we're typically looking. I really can't see anything that would indicate a P wave there to me. I'll look here in V1, and again, I'm not going to stress myself for it. I'm just going to look and say, do I see something that could be a P wave? And not really. I know these, when you see the QRS complex, I've got QRS complex. Remember, the next deflection is always the T wave. So I see lots of T waves, but I really don't see anything that would be a P wave to me. Maybe that little guy could be a P wave, but I mean, I'm seeing nothing consistently. So I am going to go ahead and say I don't see any P waves. So no P waves. And again, that makes it real easy for us when we're looking at it because if I have no P waves, I don't have a PR interval. and no PR interval. QRS, very narrow on this one, so we can see that we've got a narrow QRS. So this makes it pretty easy. Narrow QRS means it's coming from above the ventricles. I got no P wave, so I can't really tell where it's coming from. So in this instance, so it's narrow QRS complex. I don't really know where it's coming from, except for the fact that it's irregularly irregular. So in this case, this is the real outlier here, is I've got an irregularly irregular rhythm. So anytime I have narrow QRS complex, or it doesn't even have to be narrow, but I have a no P waves and an irregularly irregular rhythm, we know that we have atrial fibrillation. So this is an atrial fibrillation at 130 beats per minute. You could call this an atrial fibrillation with a rapid ventricular response or an uncontrolled atrial fibrillation, but at the end of the day, it's an atrial fibrillation at 130 beats per minute. So we're going to move on to our 12 lead here and see what do we see. And I mean, there's something immediately sticking out to me for this patient. When I look at B2 or lead 2, 3, and AVF, I'm seeing what I would expect to be massive ST elevation. So we know we've got QRS complex. This is the S wave coming up here. We've got this change in deflection. So your S or your J point is right here. So, I mean, although we don't have a great baseline on this, so it's really hard to determine, well, where's the baseline? Somewhere around here. I know it's low, so the baseline has to be before, so it could be here, probably right there, before our QRS complex starts. So our baseline looks like it's somewhere around here. I mean, I don't even have to measure it to know that I've got massive elevation here. So elevation in 2, 3, AVF. If you're really looking and you're like, okay, I'm not sure, could this be a STEMI? Is it a STEMI? What I'll typically do is go to my other leads. So I see some SD depression here. I see some flip T waves over here. So that is just giving me that reciprocal changes, or it's starting to really push me towards that diagnosis of STEMI. So we know 2-3 AVF is our anterior or our inferior leads. So we're looking at an inferior ST elevation MI. So this patient has an atrial fibrillation and is also having an inferior STEMI. So again, we know that because we've got elevation in 2, 3, and AVF, and we're seeing some reciprocal changes in the form of depression. So again, if you're having a hard time seeing that, just draw that line from your other QRS complex or from your PR interval. Got some depression here, or I'm seeing these flip T waves, which would be constituting those reciprocal changes. So this patient, atrial fibrillation, 130 beats per minute with an inferior STEMI. So we're on to our final rhythm here. So we'll take a look. So this one's really hard because I don't have any lines. So I mean, it looks fast to me. I wouldn't be able to tell you what the rate is for this patient specifically because I can't see it. So I'm just going to assume it's fast. Like I said, I'm having a hard time reading it here, but it looks fast. So we'll say fast. Who knows? Maybe. Rhythm, it looks regular. So I'm seeing, okay, yeah, these look fairly normal. So that's a regular rhythm. So rhythm is regular. I'm going to, this is our lead 2 here. So we'll start looking for our P waves. So are there P waves present? Remember, again, if you're having a hard time, we know that the big deflection after the QRS complex is always going to be your T wave. So I've got a P wave here, P wave here, P wave here, P wave here. So looks like I've got a P wave before every complex. Unfortunately, I can't tell how wide it is. So the only thing without the boxes here is we don't know if this is a first degree block or not. So P waves are present, they're upright, and they look the same every time. So they're present, they look the same. They're upright. So that's all great news. Tells us it's coming from the same place. Again, for us, we know that place is likely the SA node. So because I got P waves that look the same, they're happening every time. I can see, and the PR interval looks like it is probably not long. Again, without the boxes, it's hard to tell, but we'll say not long. Doesn't seem like it. So it doesn't look, or it doesn't appear to be too long. So what we likely are looking at here is an impulse coming from the SA node traveling down to the AV node. We're not seeing any problems there yet. likely going from the AV node to the QRS complex, which does appear wide in this case. So even in lead 2, again, we don't have the boxes, but it appears wide. So that gives us a lot of information. So in terms of naming it, it's easy. We've got P waves. We don't think we have a long PR interval. Every P wave precedes a QRS complex. That tells us it's sinus. So we've got a sinus rhythm at some rate, and likely it's so we've got a sinus rhythm at some rate. There's something abnormal about it. Its QRS complex is wide, so we can call that something. So we have a sinus rhythm. We don't necessarily want to call it normal because something is weird because the QRS complex appears wide. So we've got a sinus rhythm at some rate with aberrancy. And that's just telling you that or it's telling someone that when you looked at the QRS complex, it was wide. So sinus rhythm with aberrancy is what we're looking at in this case. Now, what's interesting about this is we have to start going through to see is something else going on here with our 12 lead. So we start looking at and again, this is where you would take a look, and my eyes are immediately drawn to V1 and V2 here. So that's likely the first place that I would look if I was looking at this 12 lead. So because I'm seeing, well, oh, that looks kind of weird, or looks not necessarily normal, that would be the first place that my eyes would be drawn. And we see this wide QRS complex. So we're looking from basically here to here. This is going to be wide. If we have the ratings on it, it would tell us it's wide. We see a negative deflection, so we've got this negatively deflected QRS, which tells us that the impulse is traveling down the left bundle branch slower than the right. So we're getting that kind of slower progress or slower movement. So it's kind of moving slowly down V1 here. And that's telling us that we have this left bundle branch block. So we can very clearly see here that we have a left bundle branch block. Negative deflection, which a wide QRS complex left bundle. Just to give you a little bit of understanding of why you see that negative deflection is we know we're looking at impulse moving away. So in V1, your camera isn't looking right at, we know it's looking at the septal part of the heart. So we've got kind of like this septal or picture kind of looking in here. So in V1, we're looking at the septum, which tends to favor the right bundle branch a little bit more. So when we have an impulse that's moving more slowly, so again, this impulse is kind of just taking its time moving down this left bundle branch, and you can see the majority of it is moving away from that camera. So that's why we get this wide complex negative deflection, because we're seeing the length of time it's taking that impulse to travel down the left bundle. So that's why we get a left bundle branch block. So in this one, sinus rhythm at some sort of rate. We have no idea what it is in this case, but we also have that aberrancy, and that's due to the patient having a left bundle branch block. What's kind of interesting about this one is, again, we'd have to know what we're seeing in terms of how big they are. But this is a pretty deep dive deflection here. If I had to guess, I would say when you add these guys up and these guys up, this person likely has some indication that they have an LVH or left ventricular hypertrophy as well. So I hope this is helpful in your ECG reading endeavors. If not, don't watch anymore. If they are, I'll post another one next week. Have a good weekend.